Now, in order to go further with decision trees, we need to learn an important concept called entropy. Entropy comes from physics, and to explain it, we'll use the example of the three states of water. These are solid, which is ice, liquid, and gas, which is water vapor. Let's think of the particles inside ice, water, and vapor. Ice is pretty rigid, in that its particles don't have many places to go. They mostly stay where they are. Water is a little less rigid, in which a particle has a few places to move around. And water vapor is in the other end of the spectrum. A particle has many possibilities of where to go and can move around a lot. So entropy measures precisely this. How much freedom does a particle have to move around? Thus, the entropy of ice is low, the entropy of liquid water is medium, and the entropy of water vapor is high. The notion of entropy can also work in probability. Let's look at these three configurations of balls inside buckets. The first bucket has 4 red balls. The second one has 3 red and 1 blue. And the third one has 2 red and 2 blue. And let's say balls from each color are completely indistinguishable. So we could say that entropy is given by how much balls are allowed to move around if we put them in a line. We can see that the first bucket is very rigid. No matter how we organize the balls, we always get the same state. So it has low entropy. In the second one, we can reorganize the balls in 4 ways, so it has medium entropy. For the third one, we have 6 ways of reorganizing the balls, so it has high entropy. This is not the exact definition of entropy, but it gives us an idea that the more rigid the set is, or the more homogeneous, the less entropy it will have, and vice versa. Another way to see entropy is in terms of knowledge. If we were to pick a random ball from each of the buckets, how much do we know about the color of this ball? In the first bucket, we know for sure that the ball is red, so we have high knowledge. In the second bucket, it's very likely to be red, and not very likely to be blue. So if we bet that it's red, we'll be right most of the time. So we have medium knowledge of the color of the ball. In the third bucket, we know much less, since it's equally likely to be blue or red. So here we have low knowledge. And it turns out that knowledge and entropy are opposites. The more knowledge one has, the less entropy, and vice versa. Thus we conclude that the first bucket has low entropy, the second one has medium entropy, and the third one has high entropy. Now when I say opposites, I don't mean additive inverse or multiplicative inverses. I only mean it in the colloquial sense of the word. When one of them is big, then the other one is small, and vice versa. Over the next few videos, we'll cook up a formula for entropy, namely one that gives us low, medium, and high values for these buckets.